And I want to show how to use R&R Studio to evaluate the gamma distribution. There are three types of probabilities we might want to look at for a gamma distribution. For this, we're going to use the p-gamma command. The first number you enter is the less than number, so in this case, I want the probability that x is less than 5. So we're going to use a 5 here. We then do shape equal to, and this is the alpha value, so in this case, we're going to have an alpha of 2. We want the second one, so we want to know the probability that the second occurrence occurs in the first 5 time units. And then we have our rate, which is our lambda. And in this case, lambda is equal to 1/3. If I run this, I get the probability that my second occurrence occurs in the first 5 time units is 0.4963. The next thing I want to look at is a between probability. I want to look at the probability that my second occurrence occurs between 5 and 8 time units. So for that, I still use the p-gamma command, and I do the larger minus the smaller. So in this case, p-gamma of 8 minus p-gamma of 5. My alpha value is still 2, and my lambda value is still 1/3. So the chance that the second occurrence occurs between 5 and 8 time units is going to be 0.2489 once I round. The last type of probability, the probability that x is greater than 3, p-gamma always gives me the probability of less than, so the p-gamma of 3, shape equal to 2 and rate equal to 1/3, would give me the probability that x is less than 3. So by doing 1 minus, I can get the complement and get the probability that x is greater than 3. And we can see the probability that my second occurrence occurs in more than 3 time units is going to be 0.7357. Now let's look at the PDF of the gamma distribution. I went ahead and created this function that would actually give me the gamma distribution. I just need to input values for alpha and theta. I'm going to start by letting theta equal to 4. And then I'm going to look at various values of alpha. Let's start with alpha equal to 1/4. Now that I have that, I can plot this function. So we can plot this where x goes between 0 and 30, where theta is equal to 4 and alpha is equal to 0.25. And when we do, we have our graph here. We can see it starts very steep and then drops off and continues to decrease, but not as steep, not as quickly. Changing alpha equal to 1, we can see that it still has this same shape, although it doesn't start as high, and it's not quite as steep at the beginning. For alpha equal to 2, we can see this is very greatly right skewed, but we can now actually see a peak hump instead of just a peak over here at the left. Letting alpha be equal to 3, we can see that it's shifting closer and closer to normal. It's still right skewed, but not quite as bad. And if I change alpha equal to 4, we can see the skew is still moving further and further over. It's getting closer and closer to normal the higher I make my alpha value. Let's now leave alpha at 4 and look at changing theta and seeing what that does. Letting theta be equal to 3, you can see we're still shifting back to more and more right skewed. Theta equal to 2 is even more right skewed. Now we have theta equal to 1, we can see even a stronger right skew. In theta equal to 0.25, we also have this really, really strong right skew. So the smaller values of theta and alpha give us a more right skewed distribution, whereas the bigger values make this thing closer and closer to a normal distribution.